I welcome you once again to the next lecture of information theory and coding. In our previous class, we had taken an example. In that example, a source was given. That source was a part of the dependent source category. That means all the symbols, all the states within that source, they are mutually dependent with each other. And for that case, we had seen that how we can find out the average information of the source. And we also have seen that how to draw the tree diagram uh, in that previous example. So in this class, we will take up one or two examples if time permits. And we'll discuss a new topic that was the Shannon's, based on the Shannon's theorem. So the example is given as this. For the first order Markov source with a source alphabet ABC. Okay, so there are three. This particular source called as S, it has three alphabets called as A, B, and C. So you can call these three as the alphabets, you can call as symbols, you can call as states. Okay, shown in figure, compute the probabilities of states. So we have to find out what is the probability of A, probability of B, and probability of C. Okay, this is the first part of the question. Now, hope you understood the first part and hope you understand the diagram. You see in that diagram, the state A is dependent on itself at a probability of P. The state A has a transition from state B at a probability P. State C is dependent on itself at a probability P and has a transition to state A at a probability. So if I like to write what is the state probability expression, so what is the probability of state A? So probability of state A, I will write P. This state A depends on itself at a probability P. So this I can write P into probability of A. So what is the probability of A multiplied with the probability at which the state depends itself? Okay, then plus there is another state that is called C, which is dependent on state A at a probability P. So we can write P into probability of C. Similarly, for state B, you can write down state B depends on itself at a probability P. So I can write P into probability of B plus, let us see if any other state A, it is dependent on state B at a probability P. So P into probability of state A. So see here, if I look at the probability of A, I am not writing here this probability, that is probability of B, because the state B, it is not dependent on state A. Okay, state B is not, but state A is dependent on state B, but state B is not dependent on state A. So that's why I'm not writing here state B. Similarly, for probability of state C, if I have to write, state C depends on itself at a probability P. So P into probability of C plus, is there any other state which is dependent? See, this state B, okay, state B is dependent on state C at a probability P. So I can write P into probability of B. All right, so in this way, I have written the probability of three different states. And we know if we add the probability of all three states, so sum of all probabilities, that will become equals to 1. So using this, I can write what is probability of A that we have calculated, P into P of A plus P into P of C plus what is probability of B, that is P into probability of B plus P into probability of A. Probability of C we can write plus P into probability of C plus P into probability of B. This is equal to 1. So this we can write like this. I can take, this is P into probability of A, this is P into probability of A. So it will be 2 into 2P into probability of A. This is P into probability of B, this is P into probability of B. So this we can write 2 into probability of 2 into 2P into probability of B, and so on like that. By taking 2P as common, it will be the sum of all probability of A plus probability of B plus probability of C. So this equals 1. And we have taken that sum of probabilities of all three states has to be 1. So similarly, this sum will become 1. So we can write 2 into P, that equals to 1. So from this, we can calculate the value of P, that is 1 divided by T. So what we got at this point, the value of P, we have got 1 by. So everywhere it is written P, so that value we could able to calculate in this process. Hope you understood or you followed up to this. Now, what is the question? We compute the probability of states. So probability of state means we have to compute probability of A, probability of B, probability of C. We have to find out. All right. So if I have to write down this equation, this one, since we have the value of P, so you can put the value of P is equal to 1 by 2. So you know probability of A is equal to 1 by 2 probability of A plus 1 by 2 probability of C. All right. Now you take this to left hand side. So what we will get, it will be a probability of A minus half of probability of A. So it will be half of probability of A. That equals to half of probability of C. So half of you can cancel from both sides. So probability of A is equal to probability of C. This is what we got. Now you can take the second equation. So probability of B is equal to 1 by 2 into probability of B plus 1 by 2 into probability of A. By using the value of P, I have rewritten this particular equation. Again, let us take this term to left hand side. So we will have half into probability of B is equal to half into probability of A. So what we'll get, probability of A is equal to probability of B, and cancelling half from both of the sides. The same thing we will do. The same thing we will do for the third equation. So probability of C, that equals 1 by 2 probability of C plus 1 by 2 probability of B. And again, I will take to left hand side. So it will be half into probability of C is equal to half into probability of B. Okay, on cancelling half both of the sides, we will have probability of B is equal to probability of C. Now we got probability of A is equal to probability of C. Probability of A is equal to probability of B. Probability of B equal to probability of C. That means we can write probability of A is equal to probability of B is equal to probability of C. Even no need to calculate this particular step. In this particular step, you also can come to this particular conclusion. All right, and since all probability of all the states are same, or all states are equal probabilities, and sum of all the probabilities is equal to 1, so we can write the individual probability is equal to 1 by 3. So individually all states have a probability 1 by 3, and if we add the probability of all states, then that will be 1. So their respective probability will be 1 by 3. Okay, so we calculated the probability of states. Now let us calculate what is the value of HS. Okay, that is the average information. Okay, so how we can calculate the average information? The average information H of S can be calculated like this. I is equal to 1 to 3, because here we have 3 different states, and probability of I log base 2, 1 divided by probability of I. So probability of 1 log base 2, 1 by probability of 1 plus probability of 2 log base 2, 1 divided by probability of 2 plus probability of 3 log base 2, 1 divided by probability of 3. So here we have the states whose names are A, B, and C. Okay, that means P1 stands for PA. Okay, so P1 is nothing but PA, P2 is your PB, P3 is your PC. Okay, and that is P of A, P of B, P of C is 1 by 3. So it will be 1 by 3 log base 2, 3 plus 1 by 3 log base 2, 3 plus 1 by 3 log base 2, 3. Okay, so that is nothing but it will be log base 2, 3, because all 3 terms are same. So we can write this as 3 into 1 by 3 log base 2, 3. So 3 cancel. So we'll have log base 2, 3. So log base 2, 3. This answer will be calculated. Yeah, oh. Oh, sorry. One mistake here is that when we have calculated the average information, we should calculate average information by considering their dependability. So this particular expression what we have calculated, this is for the case when the sources are not dependent, or that is zero memory source. But this particular example is not part of zero memory source. So in order to calculate the average information, first we have to calculate the average information of the state. What is the average information of state A, state B, and say state C? Okay, so this is not correct. That means here the total information of the source is equal to the summation of probability of that source into average information of the state. Here I is equal to 1, 2, 3. So this will give us the average information of the source. What is PI? PI is the state probability. That means P1, P2, P3. We have seen that probability of A, probability of B, probability of C, that is 1 by 3. And HI, so what is H1? H1, H2, H3. So H1, H2, H3, these are the average information of state 1, state 2, state 3. But in this figure, we don't have state 1, 2, 3. We have state A, state B, state C. So H1 is our HA, H2 is our HB, and H3 is our HC. Okay, so how we can calculate the value of HA? So HA can be written like this. It is the summation of J is equal to 1, 2, 3, because you have all total 3 states in this particular example. Probability of Ij. Okay, if you recall, I am writing from the basic for your understanding. This is the equation. H of I is equal to, because it is in that formula, H of I. So the formula of H of I is P of Ij log base 2 1 divided by P of Ij. This is the general formula of individual state information. So if we consider I is equal to 1, then it will be H of 1. So H of 1 is nothing but our H of A. That means we will take I is equal to A, B, and C. So when I is equal to A, then H of A is equal to summation of J is equal to, we'll take A to C rather than taking 1, 2, 3. We'll take A to C because the states are numbered as A, B, C. The states numberings are not 1, 2, 3. That is the reason. So P of A, J, because this is I, in place of I, we have written A, so A and J. So log base 2, 1 divided by P of A, J. This, on expanding, we can write P of AA log base 2, 1 by P of AA plus next value of J will be B, but the value of I will not change because I we have considered A. Okay, so for that case, we are calculating HA. Only J is changing in this summation. So J will be A, J will be B, J will be C. So probability of AB log base 2, 1 divided by probability of AB plus probability of AC log base 2, 1 by probability of AC. Hope you all followed up to this. So what the meaning of probability of AA? It is the probability at which a source A is dependent. A source A is dependent on itself, or it is dependent on A. So a state A is dependent on state A. That means what is the probability of self-dependency? Okay, so that is the meaning of PAA. So if you look here, the probability that state A depends on itself is 1 by 2. So this we can write 1 by 2 log base 2. 1 by 2 I can write 2 plus probability that state A depends on state B. Look at the diagram. State A depends on state B. At what probability? 1 by 2. So 1 by 2 log base 2, it will be 2 plus state A depends on state C. Now you see here, state A has no dependency on state C, rather state C depends on state A. So here, what is the probability that state A depends on state C? We can write it as 0. Okay, so this term will be 0. So 0 multiplied with anything, it will be 0. So we know what is log base 2, it will be 1. Log base 2, it will be 1. So 1 multiplied with half will be half. So here half plus half will be 1. So the answer is 1 bit per symbol. This is the value of h of A. Further, if we take the next value of I is equal to B, if we take, so we will calculate h of B. That equals summation of j is equal to A to C, probability of bj log base 2, 1 divided by probability of bj. Okay, are you getting? Because this value b is fixed, I value is fixed. So that is probability of b. J value will change from A to C. So it will first will be A log base 2, 1 by probability of BA plus probability of BB log base 2, 1 by probability of BP plus probability of BC into log base 2, 1 by probability of BC. That is probability that state B depends on state A. In this diagram, this is state B. What is the probability depends on state A? There is no probability. But A depends on B, but B does not depend on A. So that will be 0. Probability that B depends on itself, that probability is 1 by 2. So it will be log base 2 plus B depends on C. This one, probability that state B depends on state C. Let us see whether it depends or not. Yes, state B depends on state C at a probability 1 by 2. So we can put here the value as 1 by 2 log base 2. So this will become again 1. So 1 bit per symbol. Similarly, for the final value of I, that will be C, we will calculate the average information for state C, that is equal to J is equal to A to C, probability of Cj log base 2, 1 divided by probability of Cj. Okay, so you can expand this like this, what I have done, and finally you will also get the result to 1. So this result will be 1 bit per symbol. So what we got, HA value is equal to 1 bit per symbol, HP value is also 1 bit per symbol, HC value is also 1 bit per symbol. Now we have to calculate the value of H. Okay, so how we can calculate the value of H? So HS is now equals to, I will expand this summation, it will be P1 H1, but here the states are not named as 1, 2, 3, they are named as ABC. So you can write PA HA plus PB HB plus PC HC. Okay, so what is PA? It is the state probability of state A. So we have here obtained probability of A is equal to 1 by 3. So all states are having probability 1 by 3. So here 1 by 3 into what is HA we got? HA value we got 1 bit. So it will be 1. Then plus here also 1 by 3 into 1 plus 1 by 3 into 1. So this will be 1 by 3, this will be 1 by 3, this will be 1 by 3. So final what we will get 1 bit per symbol. Okay, so this is what we obtain. It is the average information of the source. So in order to calculate the average information of the source, so first we calculated the average information of each states individually, like HA, HB, and HC. After that, we calculate the average information of the source using this particular formula. So that also we got 1 bit per symbol. Okay, is it clear? Now, let us come back to the question, if anything else. Find HS. So we could able to find the value of HS. Now, H of S square. Okay. What is H of S square? So H of S square represents the average information of second extension of source. Okay, that is the meaning of S square. S square means that you have to calculate the second extension. Okay, so if we recall, we have a general formula. What is the average information of S to the power n? This is nothing but n into H of S. That means if you want to find out the second extension, it will be 2 into HS. If you have to find the third extension, it will be 3 into HS, so on like it is. So we are calculating what? H of S square. So H of S square is nothing but 2 into H of S. Okay, so we have here the value of H of S here, that is 1 bit per symbol. So this equals 2 into 1 bit per symbol, that is equal to 2 bit per symbol. So this is the result of the last bit of the question to find H of S square. I think it is clear to all. No question at this point, I believe. Okay, so let us move to the next question. So students, what I will expect from you that I will not solve this particular example. Rather, I will tell you how we can solve this example. This is given. Consider the state diagram of the Markov source of figure. This is the figure of Markov source. Compute the state probabilities. So we have to calculate what is the probability of state A, probability of state B, probability of state C, and probability of state D. Okay. And one more thing I will tell you, this thing which is given, this is wrong. Okay, keep a note on this. I will be sharing the notes with you. So kindly make a correction. This dependency, the state depends on itself. State D and state B depends on itself at a probability 0.6. It is wrongly given. So you just ignore this. So this is the exact figure which is given. So we have, first of all, we have to find out the individual state probabilities. Then next bit, we have to find the entropy of each state. That means we have to calculate H of A, H of B, H of C, and H of D. Okay, entropy of each state. Then find the entropy of the source. And from that, we have to find out what is H of S. All right. So the approach is same. If you understood this particular example, so if you understood this, then there is no difference in that. You can apply the same concept, your same understanding here also. But you have to write the equation first. See, I will start from state A. So what is the probability of state A? Okay, the state A depends on itself at a probability 0.6. So I can write it as 0.6 into probability of A. All right, then so state A depends on state B at a probability 0.4. So it will be 0.4 into probability. No, it will be not 0. It is dependent on state B, but state D is converting to state A at a probability 0.5. So 0.5 into probability of D. Okay, don't confuse. 0.4 is the probability at which state A depends on state B. So that we write as this 0.4 is probability of A, B. Okay, don't make it in a ambiguity. This is called probability of dependency. Similarly, 0.6, this is called the probability of A. What we have used here, let us see here. Probability of A, probability of B, B. So this represents at what probability a particular state depends on other state. Okay, but when we are writing the state probability or state expression, we have to write at what probability the state is falling on itself. So 0.6 is the probability that the state remains on itself, and 0.5 is the probability that another state D, it is falling on state A. So that's why you have written 0.5 into probability of D. Similarly, if we write for state B, where is state B? This one. State B, which are the states which are coming to state B? State A. State A is converting to state B at a probability 0.4. So we can write 0.4 into probability of A. Plus, is there any other state which is coming to state B? That is state D. It is falling at a probability 0.5. So 0.5 into probability of D. Similarly, probability of C, if you have to write, this is the probability C, the probability at which the state C remain in the same state, that is 0.6. 0.6 into probability of C, plus any other state which is converting to state C, then state B at a probability 0.5. 0.5 into probability of B. And similarly, probability of D, if you have to write, then who is the C is converting to D, there is a transition at a 0.4 probability. So 0.4 into probability of C plus any other state which is coming to state D, state B at a probability 0.5. So 0.5 into probability of B. Got the point? Okay, so in this way, we could able to write 4 different equations. So if you see how many unknowns are here, this is one unknown, this is another, this is another, this is another. So I have 4 unknowns and I have 4 equations. So by solving them, you can easily find out the value of PA, PB, PC, PD. Got the point? Okay, so this equation, you can make one more equation out of these. What is that equation? We know that P of A, sum of all probabilities is equal to 1. So P of A plus P of B plus P of C plus P of D, that equals 1. So you have the value of P of A, P of B, P of C, P of D. Now you add off. So use this for the as the value of P of A, P of B, P of C, P of D. And you will again get one more equation. So in this way, by solving this, you can find out the value of P of A, P of B, P of C, P of C. Even this particular equation is not required in finding the value of P of A, P of B, P of C, P of C, D. Using this equation also you can find out, because you have 4 unknowns and you have 4 equations. So individual state probabilities you can find out. All right. Then this is what has been asked in the first bit. So this is how you can find out. Second, you have to find out the state entropy or average information of each state. Okay, so what is the formula we are using for average information of the state? Hi is equal to summation of j is equal to 1 to up to what is the maximum state. Here we have 4 states, P of ij into log base 2 1 by P of ij. So this particular formula we are using. So what is I? I represents the current state. If I am finding the state information for state A, then the value of I is equal to A. Okay, and the value of J, it will range from A to D, because how the state numberings are not 1, 2, 3, 4, they are A, B, C, D. Okay, so I am writing only for HA. The rest of the thing you can note. So when I is equal to A, so when J is equal to A, so I is equal to A, J is equal to A, so it will be AA. So probability of AA into log base 2 1 by probability of AA plus I is A, I is not changing, only J's are changing. So J will be B now. So probability of AB log base 2 1 by probability of AB plus probability of AC into log base 2 1 by probability of AC plus probability of AD into log base 2 1 by probability of AD. So this is what you will get. Now you see, do you have all probabilities? So probability of AA, what is the probability? The state A depends on itself, that is PAA. Look at the diagram. Does the state A depends on itself? Yes, it depends on itself. I have also written here PAA 0.6. So P of A value, it is known. So this particular term will be known. PAB, does the state A depends on B? Let us see in that diagram. State A depends on state B. Yes, I also have written here PAB 0.4. So This one also you can find out. Now let us see PAC. Does the state A depends on state C? State A on state C. Where is state C? It is here. So there is no dependency in between state and state A and state C. So probability of AC, this will be 0. So this term will become 0. Then does probability of A depends on does the state A depends on D? State A, no. But state D depends on state A, but state A does not depend on state D. So this term will again become 0. Only you can take these two terms to find the answer of HA. So similarly, you can find HB, HC, and HD. Okay, so this is the second part of this question to find out the state informations. And finally, you have to calculate what is the average information of source, not state. But these four things gives the average information of individual state, not the source. But this particular term will give you the average information of the source. So how we can find out? So you have to use this formula. H of S is equal to summation I is equal to 1 to up to how many states you are having. You have four states. So the states are here A, B, C, D. So A to D I will write. Then probability of I, okay, or probability of I into H of I. So that equals to probability of A into H of A plus probability of B into H of B plus probability of C into H of C. So in bracket, this is, or anything you can write, it is up to your understanding, plus probability of D into H of D. So you have calculated PA, PB, PC, PD. So these values you have calculated. And HA, HB, SC, HD, that also you have calculated like this. So using those values, you can calculate easily what is the average information of the given source. Okay, so though I have not solved this example, so this is I am giving you as an home task. You can try at your home and you can check the result. Okay. So with this, the first part of module 1 of information theory and coding is complete. In the next part, we will see what is the source encoding. And we will see what is the Shannon's algorithm of source encoding. So general question may arise that what is the need of source encoding and what do you mean by source encoding? Okay, source encoding means suppose a given alphabet is given, a given message is given. When a certain message is converted to a some set of code, so that process is called as encoding. So by using the encoding techniques, we convert a message or we convert an information into some code word. So this code word we can follow of many types. There are different coding techniques are there in order to generate a code. Then question comes that which kind of code we should follow, whether we should follow this code or that code or that code. It depends on that whenever being a communication engineer, and when we want to design a communication link, the link should be a cost-effective link. And if you want to think for cost effectiveness, or if you want to make the communication system as a cost effective, then we should try to minimize the number of bits required to represent a certain message signal. If I want to transmit some message signal and I am requiring less amount of bits, less number of bits than some other encoding techniques, then my link will be a cost-effective link in comparison to the other link. The reason is that if you are requiring high number of bits to represent a certain message, that means we are transmitting more number of bits and we require more number of bandwidth, or a large bandwidth required to transmit the same message. But if someone else who is transmitting the same information or same message using less number of bits, then that link will require less bandwidth. So there is a requirement of less bandwidth and the cost effectiveness will be more. So in that way, being an engineer, we have to design a link, how the link can be cost effective and how the link can be reliability. So since we have no time today to begin a new topic, we shall discuss the Shannon's algorithm in the next class, in the coming class. And if you have any clarification or doubt or questions from this session, you can ask.